Hello everyone, and welcome to this presentation in which I'll share some stories on the need for satellite-based situational awareness in the Arctic and how satellite data can support the gap of navigational risk in these uncharted and beautiful yet dangerous waters. I'm Mikkel Bojesen. I work with DHI Glass, the leading remote sensing company in Denmark. We bridge the gap between research and industry. The Arctic is by and large uncharted, and very often we say that we do not really know where Greenland is. The patrol vessel of Knud Rasmussen from the Danish Navy learned it the hard way a few years back. The problem is that this is not a unique accident or incident. It happens across the Arctic, and it happens across stakeholders. And that's the background for the research project NANOK. The project itself is co-financed by the Danish Defence Acquisitions and Logistics Office under their industrial R&D grant. The project develops an automation and upscaling feasibility study of navigational hazards, meaning that we map coastlines, intertidal zones and submerged reefs. In a nutshell, you can say that the NANOK builds on a multi-temporal approach that gives us the opportunity to capture the entire tidal range and also remove artifacts. It works independently of any calibration data, but with the possibility to validate against any point data source, as the ISA2, for instance. It is also based on cloud compute, meaning that there's a fast turnaround time. All the way through, it has been the aim to automate all the workflows, meaning that the product is also scalable, and the ultimate goal is to cover the entire Arctic. So what are the outputs actually? We map in navigational high-risk zones in which depths are 10 meters or less. We also map intertidal zones and coastlines. Space is often not a limiting factor, but you need to know which route not to follow. For instance, if you should navigate towards this dot, you wouldn't know a priori if you should enter from the north, south, east, or from the west. If we add the coastline, then we have that one settled. In this example, the coastline was off by 200 meters in the chart, but by adding the automated coastline, then we have that problem solved. If we then add the intertidal zone marked by the green color and the high-risk zone marked by the red color, then we can all of a sudden see that we should either enter from the north or from the west. That's all basic information, and hence it is also very vital information. So that was just a brief introduction to the NANOK project. The other project I would like to talk about is the SAR for SAR project. It takes its point of departure in a distress situation in which you would need assistance from, for instance, first responders. You may find yourself in a dinghy or a life raft after your cruise ship has hit a submerged rock and is now sinking. The crew has soon realized that the EPIB or the satellite phone is not really working as they should. And also the life rafts are soon scattered over large areas. Such a situation would be a situation that the SAR for SAR is interested in. Small objects can be identified based on radar satellite imagery. It has been done before. It has been done by identifying ships. But the question is, how small objects are we actually able to identify? In order to investigate that, we carried out a project together with the Greenlandic police. And in that test, we could identify a dinghy with a length of approximately 4 meters. The problem was that we did also identify other objects. We identified wave tops, that is seen on the image in the lower left. So the issue is now to solve that problem and to amplify the backscatter signal from the object that we are actually interested in. So after all this, what are we then left with? Well, we are left with a clear impression that there is a need for situational awareness across the Arctic. In a survey that we carried out a few years back, we could also see that these areas, they should emphasize especially 4 issues: submerged in navigational hazards, search and rescue for smaller objects, ice conditions, and local tidal conditions. So that's what future research should be emphasizing. Thank you very much for the attention. If you have any questions, please email me or follow us at dhigast.com or at eo@dhi. Thank you again.